Hello and welcome. Today we're going to continue our discussion on applications of quadratic equations. First, let's discuss a scientist launched an object upward at a speed of 48 feet per second, we'll abbreviate that as FPS, from a height of 288 feet. The height, which we will call h, of the object in feet, at any time, which we will call t, in seconds, can be modeled by the following equation. So I've already written the equation for you. All we need to do is find h when t equals 1. Since we know that t equals 1, all we are going to do is look at our equation and plug in 1 everywhere that we see a t. So h equals negative 16 times t squared, or 1 squared, plus 48 times t, which is 1, plus 288. So h equals negative 16 times 1 squared, which is just 1. But negative 16 times 1 is just negative 16, so I don't need to write the times 1. Plus 48 times 1, which is 48, plus 288. Doing this math, I've got negative 16 plus 48 plus 288. Altogether, that's going to equal 320. So the height equals, or h equals, 320. So when t equals 1, h is 320. We're now going to interpret the result. To interpret, look at what we started with. We started with t equaling 1. T equals 1 means the time in seconds is 1. So we have 1 second. After 1 second, we obtained an h of 320. With h being 320, this means that our object reached a height of 320 feet. So to interpret this in a complete sentence, the height after 1 second was 320 feet. And that is how we will interpret our result. Please make sure that you are writing complete sentences when you interpret results. On this next slide, we are going to continue with the same equation and the same scenario. But what we want to know here is after how much time, so we are trying to find t, will the object hit the ground? So in order to find one of them, in order to find t, we must know the other one, or we must know h. The only piece of information that we have here is that the object is going to be on the ground. So if we're trying to find t, I need to know what h equals. If the object is on the ground, then that means the height of the object, or h, is going to equal 0. It is not off the ground at all. So since my object is on the ground, I plug in an h of 0, and I solve my equation for t by factoring. Remember, when we are factoring, make sure that you have a 0 on one side, and then factor completely. Since I do have the 0 on one side, I'm going to first factor out my greatest common factor. Between 16, 48, and 288, I may take out a greatest common factor of 16. However, looking at your leading coefficient, since it is a negative 16, I'm going to factor out a negative to make that leading coefficient positive. So I take out a negative 16 from all three of those terms. That leaves me with a positive t squared, a negative 3t, and a negative 18. Dividing 288 by 16 leaves me with 18. From here, I use the diamond on the remaining trinomial inside my parentheses. I have a negative 18 on top and a negative 3 on bottom. The left and the right of my diamond are going to consist of negative 6 and positive 3. So I rewrite that negative 3 as negative 6t plus 3t. And that t squared in front remains, as does the negative 18 behind. Splitting this down the middle, I take out a t, leaving me with t minus 6. And on the right, taking out a positive 3 leaves me again with t minus 6. Now I see two factors that are repeated, so I factor out that t minus 6, and I'm left with t plus 3. Don't forget, we still have that negative 16 on the front that must be carried down. And all of this is equal to 0. Now that we've factored completely, we take each factor containing a t and set it equal to 0. So one factor containing a t would be this t minus 6. So I'm going to write an equation where t minus 6 equals 0. And my other factor containing a t is this t plus 3. So I write an equation where t plus 3 is equal to 0. Adding 6 to both sides of my equation, I find that t is going to equal a positive 6, or subtracting 3 from both sides of my equation, I find that t is going to equal negative 3. So what we have found is that the time it's going to take for the object to hit the ground is either 6 seconds or negative 3 seconds. Now, if we're thinking about this realistically, it's not going to take an object a negative amount of time to reach a destination. So we're going to disregard this solution and say that it is going to take the object 6 seconds to hit the ground. So writing our solution in a complete sentence, it will take the object 6 seconds to hit the ground. Go ahead and take a moment to pause the video and try this slide and the next slide on your own. They are both very similar to the ones we just did, so if you get stuck, go ahead and look back at your notes for help. Plugging in a 2 for t, I obtained an h of 400, and interpreting this result, I said the object was at a height of 400 when the time was 2 seconds, or after 2 seconds. Next, the time when the object hit the ground meant that I plug in an h value of 0, and I try and find t by factoring. So plugging in a 0, I factored the right-hand side, and solving, I obtained t equals 7 or t equals negative 3. But as I discussed previously, having a time that is negative doesn't make sense. So I disregard that solution and say that it will take the object 7 seconds to hit the ground, or to reach a height of 0. Go ahead and take a moment to again try this next slide on your own after pausing the video. So the first thing I did was I plugged in a t value of 3 in order to find the d value. After plugging that t value in and doing the math, I obtained a value of 225 for d. What this tells us, the distance the object has fallen is 225 feet after a total of 3 seconds. Again, go ahead and pause the video and try this next slide on your own. Since we want to know how long it takes for the object to travel 225 meters, I plugged in a d value of 225. So plugging that in, I then subtracted the 225 from both sides to get a 0 on one side, and I factored the remaining polynomial on the left. After factoring, I set each of the factors individually equal to 0 and solved. Since one of my solutions came out negative, I disregarded that solution and only looked at the t equals 5. Interpreting my result, I found that it will take about 5 seconds for the object to travel 225 meters. We'll go ahead and stop here for today. Thank you so much for watching. I hope you enjoy the rest of your day.